Okay, so we are going to continue our analysis in solving questions together. The question states that for the circuit shown in figure 6, write the node voltage equation and find the current in the 6 ohm resistor. So the current, so we are going to find the current here and the current here. Okay, and to do this, we are going to get the branch current equation, after which we'll move on to find the what? The individual node voltages, and then we proceed to get our results, right? So realize that what this particular current and this resistance are what? Are in parallel, right? And there is something we call what? Source transformation. I've already explained this in my earlier videos, that source transformation state that what? Anytime we have resistance in parallel with what? A current source, we can transform it what? Into a voltage source in series with the resistor. Or anytime we have a resistance in series with the voltage source, we can transform it what? Into a current source in parallel with the current source, right? So let's do that. Now we know that voltage is equal to what? IR, right? So you can say the voltage will be equal to the resistance 3 multiplying the what? The current 8 amps, okay? And that will give us a resulting value of what? 24. Okay, 24 what? Volt. Okay. So we now will draw our circuit, and then it will be in series with the resistor. Okay. So our resulting circuit will be this. Okay. So our circuit will now be this, with the resistance which is the 6 ohms, and then we have another resistance which is what? Another 6 ohms here. Our voltage source is 12 volts, and then finally we have what? The resistance. Okay, so we have all these two resistors. So the resistance here and the resistance here are all in series, because we are going to have it in terms of voltage source. So we can add them together, or let me redraw the two together here. So we get 3 ohms here, another 3 ohms here, and the voltage that we have transformed, which is what? 24 watt volt. Okay, very good. So this is our resulting circuit. So we can redraw the circuit again. Okay, we can redraw it again, and then now resolve it very well, where we have our voltage source, which is the 12 volts, and then our resistance, which is what? 6 ohms, another resistance which is what? 6 ohms again, and then finally we have what? The resulting what? Resistance 3 that will give us what? 6 ohms, and then finally we have our voltage source, which is what? 24 watt volt. Okay, now after we are done with this, the next thing we are going to do is to get what? Our branch current equation. Okay, so we can say that what? This particular voltage will produce what? Current, right? And we can call that current I. When it gets here, to share into what? I1 and what? I2. Okay, so we can say it's I1 that has divided itself into what? I1, and that of what? I2. And this is what we term as what? Kirchhoff's current what? Law. Okay. So now after we are done, the next thing we are going to do is to identify our nodes, right? We have our nodes here, one node here, and then the principal node, of which that one we are going to ground it. So we can call that node what? Vn or V. Okay. So the next thing we are doing is to what? Get the node equation. So we are going to get the node equation for only one current, I. Okay, and we are saying that what? Current always move from higher potential into lower potential, right? So where it is coming from is the highest potential, and where it is going is the what? The lowest potential, right? So realize that this current is moving from this junction, this I, right? So it is coming from this side, so this is the highest potential, and then along the way there's what? Voltages on the way that is contributing. So from negative to a positive, that will give us a positive voltage source. Okay, and this is where it is going. That means the lowest potential, so we subtract it, minus Vn, all divided by the resistance 6. Okay, now let's move on to I1. So here our I1 will be equal to, so let's look at where I1 is located. I1 is here. It is moving from this side. it is moving from this side of the circuit. It is moving from this side of the circuit down here. That means that this is the highest potential, so that will be the positive. So we have Vn minus what? Where it is going, which is 0, right? All divided by what? The resistance, which is 6 ohms. Now, let's look at I2. Okay, I2 is moving from Vn. That means that Vn is what? The highest potential. And then along the way, this one will be what? Contributing negatively, so minus 24, all divided by what? The resistance, which is, of course, in this case, is what? 6 ohms. Okay, so this is basically our equation here. Now, after we are done with this, we are going to insert these individual equations into the main equation. Okay, so the main equation is I is equal to I1 plus what? I2. So what is the equation for I? I is what? 12 minus what? Vn, all on what? 6, right? Which is equal to I1. Where is I1? I1 is Vn on 6 plus what? I2, which is what? Vn minus 24, all divided by 6. Okay, so realize that the denominators are all the same, so we can just multiply by 6 and all of them will go, or we can just equate the top. So we can say 12 minus Vn is equal to Vn plus what? Vn minus what? 24, right? Okay, so then it means that what? We can send this one to the other side of the equation. Okay, so we can send this to the other side of the equation. We are going to get what? 3Vn is equal to and then move this one to the other side, which will give us what? 12 plus 24, that will give us 36. So it means that what? We can divide here by 3, here by 3. Our Vn will now be equal to what? 12. Okay, yeah. Now let's go and check in our main equation to figure out the individual values. Okay, so realize that we had what? Our I, right? Which is equal to 12 minus Vn. So that will give us 12 minus, and we know that the Vn is 12, so we just put in 12, all divided by what? 6, and that will give us 0 amps. Now we have our I1, and I1 is equal to Vn divided by 6, which is 12 divided by 6, and that will give us a resulting value of 2 amps. Now let's move on to what? I2. Okay, I2 is equal to Vn, which is 12 minus what? 24 divided by 6, which gives us what? Minus 2 what? Amps. Okay, so finally these are our results. Okay, don't forget we said I is equal to I1 plus I2, so if we check the equation, we realize that I1 plus I2 gives us 0, so that makes it very correct. Okay, so that is all for this analysis.